See how this breaks out and how long it takes us. I may not do all of it. We'll see how it goes. Okay. All right. So we are going to do example 8 just as a review of what we were doing yesterday. Okay. So we started by, let's see, we worked on the butterfly one, which was finding the values of any trig ratio given a point in the coordinate plane. So those were our first 2 examples. We found our triangles and we listed the 6 ratios. Okay. We are now working on this based on what quadrant it's in. Okay. So that we're working on the little frog problems right now. Okay. I don't know if I labeled them frog problems, did I? Let's make sure I labeled them frog problems. Let's see. I did label them frog problems. Awesome. Okay. So we should be on example 8. We've got a couple more of these. So we had gone from it just being in quadrant 1 to it being in other quadrants. Okay. And really the name of the game is this: draw the triangle in the right quadrant, use the Pythagorean theorem to find the missing side, and then write the ratio that they ask for. Okay. All right. So looking at example 8, we are given that cosine of theta equals negative 24 over 25. And the angle theta terminates in quadrant 2. What is the value of tangent of theta? Okay, so which quadrant am I needing? I need quadrant 2. So I'm going to draw a picture of my triangle in quadrant 2. Notice I emphasized quadrant 2. I don't really care about the other ones. I'm using the coordinate plane, though, to make sure my triangle is tilted the right direction so I get the signs correct. Okay, I know this is theta. I know this is going to be opposite, adjacent, and hypotenuse. Okay. We are talking about cosine. Cosine is what in SOHCAHTOA world? Adjacent over hypotenuse. Okay, so I'm putting 24 on my adjacent and 25 on my hypotenuse. Is the hypotenuse ever allowed to be negative? No, our radius of our unit circle is not negative, so I cannot have a negative hypotenuse. So where's my negative got to go? On the 24. All right, and then this is going to be, I don't know, I'm going to call it, I guess I'm going to call it y because it's vertical. So I'm going to call that side y. All right, I got to do Pythagorean theorem. So y squared plus negative 24, let me see if I can write it right. That looked weird. 24 squared equals 25 squared. All right, we're going to use the walls. Oh, why did I write an equal sign? All right, what's 24 squared? 576. Somebody found it on the wall. What's 25 squared? 625. Perfect. Okay, how do I move the 576 to the other side? Subtract it. Good. So when I subtract that, what do I end up with? What was it? 49. Okay, how do I undo the square? Square root. Technically a plus minus. In this case, I need it to be a vertical distance up. So do I want it to be positive or negative? Positive. Good. So there's a 7. Okay. We're not quite done with the problem yet, right? We still have to find what tangent is. So in SOHCAHTOA world, what's tangent? Opposite over adjacent. So I'm going to use 7 over negative 24. And is it okay to put the negative in the bottom? Is it okay to put the negative in the top? Is it okay to put the negative out front? Yeah. So you can put the negative wherever you want as long as you've got it there. Okay. All right. Let me see how many more of these we have here. 9, 10, 11. Okay, perfect. Okay. Let's start. I'm gonna start us on example 9 and have you kind of keep going on it. Okay. Let's make sure, because I don't know that we've drawn a quadrant 4 triangle yet. I don't think we have. So let's draw a quadrant 4 triangle together and make sure we understand that. So we were given that tangent of theta equals negative 7 over 24, and that the angle terminates in quadrant 4. What is the value of cosine of theta? All right. So I want a quadrant 4 triangle, so it's going to look like this. Okay. I know that this is going to be opposite, adjacent, hypotenuse. Okay. Here's what I want you to try. Without me, try it. It'll take you like 10 seconds. Okay. I want you to try to label the sides of the triangle with the tangent values there. Okay, so label where you think those go, and we'll check it. Okay, what did we, tangent is what over what? Opposite over adjacent. So where did my 7, or what went on my opposite leg? 7. What went on my adjacent leg? But one of them has to be negative. Which one was negative? 7, because the 7 went down, right? So that has to be where the negative goes. Okay. All right, here's what I want you to do next. Okay. I want you to use the Pythagorean theorem, find your hypotenuse, and then also answer what the cosine of theta is. So I'm going to give you a minute to try that part. So you're getting a little bit of this, okay? Try to do a little part of it. Okay, let's take a look at it together. Okay, so we are going to do, what were my legs for my Pythagorean theorem? What'd you use? Yep. Does the negative matter on there on this case? No, we don't have, because it's going to be squared away anyways. All right, what was 24 squared? 576. Okay, what was 7 squared? 49. What's 576 plus 49? Take the square root. 25. Didn't that look familiar? Wasn't it the same triple that was on this problem here? That was a total accident. All right. What is, you had to find the cosine. What'd you get for cosine? 24 over 25. Okay. All right. Here's what I want you to do. I don't know that we really need to do, I think there's 2 more of these total. I don't think we need to do 2 more of them. Okay. Let me see what this one looks like. Tangent to, okay, perfect. All right. I want you to try just example 10. Okay. From beginning to end on your own. So draw your own triangle, get it labeled, figure out what the third side is, and then figure out the ratio. So I'm going to give you like 2 minutes right now to do that. So everybody's trying this problem right here, okay, on your own, to make sure you can get it. Do it. Let me give you about 30 more seconds on your own. Let's talk about it together. All right, so what quadrant did you draw? So I'm in quadrant 4, drawing my triangle here. Okay. So this is my opposite, my adjacent, my hypotenuse. What is tangent? What over what? Good. So opposite 11, adjacent 60, but where'd my negative go? 11. All right, so I had to do negative 11 squared plus 60 squared. I'm doing a terrible job writing. Equals, we're going to go with x squared. Actually, I'm going to use y squared because it doesn't matter, does it? Because it's r, isn't it? R squared. It doesn't matter what you use, though. All right, what was 11 squared? Good. What's 60 squared? 3,600. Okay, and then when we add that up, what do we get? 3,721. Did it have a nice square? It was 61. Delta Math worked really hard to use Pythagorean triples, didn't they? That was really nice of them, actually, for you. All right, so what is the cosecant of that? Hypotenuse over opposite. So I heard 61 over negative 11. And again, it could be on the bottom. It could be on the top. You could float it out front. Okay. I don't feel the need to do example 11. How does that sound? Let's get rid of that one. Okay. All right. So we're going to switch gears just a little bit. Okay. So as far as the Delta Math that was already assigned yesterday, you should now be able to do all of that. Okay. Because that was those previous examples. Okay. So these ones are starting to get into the territory of this third I can statement. Okay. So we're going to find any values of trig ratios given one trig ratio and the sign of another. So we're getting into the bunny problems. Okay. Let's see if I can copy that and label these ones the bunny problems. Okay. Where are they at? Here we go. All right. This one is kind of a almost bunny problem. Oh, the bunny did not go in the right spot that I wanted him to go. Okay. Let me see if I can get him in the right spot. All right. And then, but these ones here, this is kind of the preview. Okay. These ones here are the exact places where the bunny problems really start is at 14. Okay. All right. So we are supposed to state the quadrant in which theta lies. So we're kind of, again, taking a baby step into the next set of problems. That's why there's only 2 of them. Okay. So here's what I do with this. I draw my little quadrant. Okay. And I do my all students take calculus thing because I know that there's certain things positive and certain things negative in different quadrants, okay? So I'm trying to identify where something is happening. When I say sign is greater than 0, what does that mean? What's greater than 0 mean? Positive. So that's another word for it's math symbols for saying positive. So I look at my unit circle quadrants. Which quadrants is sign allowed to be positive in? 2 and where else? 1. Okay. And their names are 1, 2, 3, 4. Okay. We use the all students take calculus thing to help us remember, right? Okay. So I know that my answer would have to be in either 2 or 1. Okay. Now we're going to look at the second piece of information, which says cosine less than 0. What's less than 0 mean? Negative. So out of these 2 quadrants only, which one is cosine negative in? Only negative here. So our answer is quadrant 2. Okay. All right. Let's look at the next one. So again, I'm setting up this thing so I can all students take calculus. So that way I am ready for circling parts, right? So I can kind of narrow down what I have. Okay. So it says secant less than 0. What's less than 0 mean again? Negative. So which quadrants is secant negative in? I heard somebody say 2 and 3. Good, because you got to think, okay, that's the reciprocal of cosine, right? And cosine's positive here. So where is cosine negative or secant negative? It has to be these 2. Because everybody's positive in quadrant 1, right? Okay, now I'm going to look at the next piece of information. It says tangent is greater than 0. What does that mean about tangent? Positive. So out of these 2 quadrants that are left, which one is tangent positive in? 3. So I know that my answer here is quadrant 3. Okay. All right. So what we're going to do in 14 is we're going to kind of combine together our quadrant thing that we were doing up here on these examples with what we just did with those signs. Okay, so I've got to figure out what quadrant I am in. They didn't tell that to me. Okay, and then I've got to figure out the other trig ratios. Before I do any of that, though, can't I get one of my trig ratios for free? Can't I use a reciprocal? So I'm going to do that first. What's the reciprocal of sine? Cosecant. So I'm just going to literally flip that upside down. Okay. All right. Now let's talk about where our triangle should be. Okay. So I'm going to do my little all students take calculus. Kind of my side work here. What sign is on the sine value? It's negative. Even though it didn't say less than 0, but that says that it's a negative number, right? So I know it's got to be negative. So which quadrant is sine negative in? 3 and 4. So I know my answer, my triangle has to be either in 3 or 4. All right. What's it saying about cotangent? Positive. Okay, so out of these two quadrants, which one has cotangent positive? 3. Okay, so that means when I go to draw my triangle, I am drawing a quadrant 3 triangle. So we just extended the idea of what we had. Okay. The rest of it is no different than what we had before. Okay. So we have opposite, adjacent, hypotenuse. All right. Sine is what over what? Okay, so opposite is going to be 2. Hypotenuse is going to be 3. Which one gets the negative? 2, because my hypotenuse can't be negative. All right, this one's not as nice. It's not a Pythagorean triple. I'm sorry. We've got to find that other side because we got to find the other 5 trig ratios, right? So I'm going to use Pythagorean theorem. I'm going to call this x. So negative 2 squared plus x squared equals 3 squared. All right, what's negative 2 squared? 4, good. What's 3 squared? Good. How do I move the 4? Good, so it's 9 minus 4? 5, good. All right, how do I undo the squared? Square root, were you here yesterday?
No.
Okay, let me get your notes. Okay. All right, it's either plus or minus square root of 5. Those ones. Let me see. Oh, there they are. There you go.
Thank you.
Okay, what should it be? Positive or negative?
Negative.
Negative. I went to the left, right? So that's negative square root of 5. The good news is I don't have to do can and can't do boxes. I wasn't that mean. Okay. All right, now we're ready to do our other trig ratios. Okay. So I have sine and cosecant. I'd probably do cosine next. The order does not matter whatsoever. Okay. All right, cosine, adjacent over hypotenuse. So negative square root of 5 over 3. What do I get for free from cosine? Secant, the reciprocal, right? So I'm going to flip that over. Negative 3 over square root of 5. And remember, my negative is just floating out in front. Do I get to leave it like that? No. What's the process called? Good. Rationalize. So I get negative 3 square root of 5. What's my denominator going to be? 5. We're getting much better at that, right? Because I told you we were going to see it 5 million times, right? We're at about 4 million right now. Okay. All right. We got 2 more. What's missing? Tangent. Okay, so tangent of theta equals opposite over adjacent. What's on my opposite? Negative 2. What's on my adjacent? Negative square root of 5. All right, here's something nice, and this should kind of, your brain this should help you kind of self-check it a little bit. What happens with the double negative? Shouldn't tangent be positive in quadrant 3? That's something that we know, right? Okay, before I rationalize, I'm going to go get cotangent. So I'm flipping this, square root of 5 over 2, and then I'm coming back to tangent, and I'm rationalizing it. So I get 2 square root of 5 over 5. Okay, we're going to try a couple more. I'm not sure we're going to finish all the way today. We'll finish them tomorrow probably. Okay, let's keep going with this concept right here. Any questions on that one? Okay, so it's kind of more of the same. What's wrong? Oh, there's a line, but yes. Okay. All right. Here we go. All right. I'm gonna give you a little bit more to do on your own this time. Okay. All right. So first thing I want you to do, okay, you're listening, okay, is I want you to figure out. First of all, I want you to find the reciprocal one. So find the reciprocal one quick. That should take you 10 seconds. Okay. What's the reciprocal one? Secant, and that is 5/3. Perfect. Okay. We need to figure out what quadrant we're in. I want you to figure out what quadrant you are in. So you do that part. Remember, use the sign that's in front of the 3/5. Okay. Is this cosine positive or negative right now? There's nothing there, so we know it's positive, right? Okay, so which quadrants is cosine positive in? 1 and 4. So I know I have to be in either 1 or 4. Okay. All right, then we're looking at tangent. What's less than 0 mean? Negative. Okay, so out of these two quadrants, which one is tangent negative in? 4. So I know I have to draw a quadrant 4 triangle. Okay, and then I'm going to put my opposite, my adjacent, my hypotenuse. Oh, what am I drawing? A high B? Where did that even come from? My hypotenuse. Okay, here's the next piece, and I know you can do this, okay? I want you to label your sides, okay? Something seems wrong. Okay, now that your sides are labeled, if you haven't gone and done it yet, do the Pythagorean theorem. Unless you know the triple, it is a triple. Yep, we'll do that in a second, okay? All right, let's check here before I have you do all 5, okay? Because don't get too excited about all 5. What was my other leg? 4. Okay, but what should be special about that 4? It's negative because it's going down. So we still have that piece like we did in the previous set of examples. Okay, so make sure your sign is correct. All right, now that you have all the parts, get the other 4. So find your other 4 trig ratios. I'm going to give you a minute and a half. Okay? So find the other 4 trig ratios right now. You can do this. Okay, we're going to share with our table partner. Okay, so the person who has shorter hair, you're going to tell them what you got for sine and cosecant. Okay, and the person that has longer hair, you're going to tell your table partner what you got for tangent and cotangent. All right, so talk to somebody at your table right now. Share those answers with the person with shorter hair and longer hair right now. Go. Okay, let's take a look now. You're going to help me. You talk to your table partner, so you should know this answer, right? Okay, what did we get for sine? Negative 4/5. What about cosecant? Yeah, and does the negative matter where it's at? No. Okay, what about tangent? What do we get for tangent? Good. And for cotangent? Good. All right. Not hard. It's just a different way of asking the same problem again, right? Okay, let's try this one. So they start getting a little trickier. Okay, so I gave you one that was pretty easy together. So let's start the process the same. Okay, let's try to figure out what quadrant we're in. Actually, before we do that, we usually do the reciprocal one, right? Technically, what's in the denominator there? 1. Okay, so what is my reciprocal of cosecant? Sine. And what are we going to get for sine then? Good. Okay, we've got to figure out the quadrant. You guys figure that out again. Figure out what quadrant we are in. Okay, I want you to really quick check it with your table partner again one time. See if you guys got the same one. Okay, my cosecant or my sine have to be negative. What quadrants does that happen in? 4, where else? There's no quadrant 5. 4, what else? 4 and 3. Okay, it's okay. Your brain just grew, and that's a good thing, right? Brains growing brains are good. All right, cosine less than 0 means what? Negative. Okay. Which one is cosine negative in? 3. So you should have gotten quadrant 3. Okay. All right. Here's what I want you to do again. I want you to draw your picture in quadrant 3. Okay. We got opposite, adjacent, hypotenuse. All right. I want you to figure out the sides of your triangle. It's not a Pythagorean triple this time. Okay. So you're going to have some radicals in there, and that's okay. Just do the Pythagorean theorem part. Don't go further than that. Let's check it before we go on to the other piece. Okay. Okay, look at mine. Do you agree with where I put my -1 and my 5? Okay, perfect. And actually, I didn't use this. I used this one, and that's okay. All right, because that's still the same ratio, right? Okay, got to use Pythagorean theorem. So -1 squared plus x squared equals 5 squared. What's -1 squared? What's 5 squared? 25. Uh-oh. Okay, what am I going to do to move the 1 over? Subtract. What do I get? That wasn't very nice of me. We haven't done one of these in a while. Okay, so I've got to undo the square root, or undo the square, right? All right. Technically, remember this thing? This is good review for us back, so we might as well do it. What's the biggest square number that goes into 24? 6 isn't a square number. 4, how many times? 6. What's the square root of 4? 2 square root of 6. That was really not nice of me. Ooh, do I want the positive one or the negative one? Negative. Okay, now that you have that, All right. Now do your other 4 ratios. Everybody's trying it right now. Why the negative? Because it was on the left versus the right. It's on the left part of the axis. Yeah. Mm-hmm. You're done. And there's a line. This is probably going to be the last one I do. Okay, we're going to check it together. No matter where you're at, let's stop and look at it together. Okay, so I put cosine next. What did you get for cosine? What over what? Over 5. Perfect. Okay, I'm going to flip that for secant, right? So in 5 over 2 square root of 6. I do not need to multiply the 2, only the square root of 6. So it's just the radical when you rationalize. So negative 5 square root of 6 over 2 times 6. What's 2 times 6? 12. Good job. Okay. Tangent. Okay. I have to do the opposite over the adjacent. So what was my opposite? Negative 1 over... Good. And what happens with my double negative? Positive. And then this, I'm going to flip it, right? I don't really need the 1 in the denominator. And then I'm just going to rationalize the 6 part. So I get square root of 6 over, we get 2 times 6 again. What's 2 times 6? 12. I probably wouldn't be that nasty to you on a test. Okay. All right. That's where I'm going to stop. I believe there's some delta math out there from yesterday. This piece here, I'll group together on a worksheet with this last little bit. This last little bit won't take us very long tomorrow. Okay. But you'll need your unit circles for that part tomorrow. Okay. Osvaldo, you can go right now. Be quick, though. You want me to go back up? Yep. Just that one.